Example 1.2, find the adjoint of the matrix A. This matrix is a 3 cross 3 matrix. It has 3 rows and 3 columns. So we say that the order of this matrix is 3 cross 3. We want to find out the adjoint. Adjoint is the transpose of cofactor matrix. So you have to find cofactor of this, cofactor of this, cofactor of this, like that. You will have to find the cofactor of all the 9 elements. Then what you get will be the cofactor matrix. And when you want to find out the cofactor matrix, cofactor of this would be the neglect the row or reject this column and this row. You will have this as a 2 cross 2 determinant. That will be plus, because whenever you want to put the sign of the cofactor, it will follow the order plus minus plus minus plus minus etc. starting from here. Plus, cofactor of this will be plus, this will be minus, this will be plus, again this was plus, and now it will be minus, plus, minus, like that it will go. It will simply alternate between plus and minus. And to find the value of the cofactor, suppose you want to find the value of the cofactor 1, forget the column through this and row through this. The evaluate the determinant of the remaining elements. Similarly, for this, forget the column and the row through that. The remaining elements will form a determinant 1, minus 3, 2, 3, like that. Evaluate the determinant, then minus of that determinant value will be the cofactor of this, because this was plus, this would be minus, again this would be plus, like that it goes. Now you can see this, the cofactors are given by cofactor of 1, which is represented as A11, capital letter A. The meaning is cofactor, this capital A indicates cofactor with the subscripts 1 and 1. 1 and 1 say that it is cofactor of the element on the first row and the first column of the matrix A. So you just leave this column, leave this row, 2, minus 3, minus 1, 3. This is a determinant. Evaluate the determinant, you will get 3. So cofactor of 1 is 3. Then cofactor of 1, this one. So this column and this, this row and this column is, they are to be rejected or neglected. The remaining elements 1, minus 3, 2 and 3 will be, you have to evaluate the determinant. Negative of the determinant will be the cofactor of this one. A12 represented as A12, meaning cofactor of the element of the first row and the second column in the matrix of A. Similarly, cofactor of 1, A13, that is of this. Determinant is 1, 2, 2, minus 1, it is plus. So 1 into minus 1 is minus 1, minus of 4. So minus 1 minus 4 is minus 5. Similarly, cofactor of 1, A21, that is the element in the second row and the first column, this one. So you leave this column and this row 1, 1, minus 1, 3, and it should be considered with the negative symbol. That is negative of this determinant you have to consider, which is minus 4. You see this 3, minus of minus 1 is 4, plus 4, but there is a minus symbol outside, so you will get minus 4. Now cofactor of this 2, A22, the determinant is 1, 1, 2 and 3, and 3 minus 2 is 1. Similarly, cofactor of minus 3 represented as A23, minus of this determinant 2, 3, second row, third column, second row, third column. So this and this 1, 1, 2, minus 1. You see 1, 1, 2, minus 1. That is for the cofactor of minus 3, which is here. So you will have plus 3. Actually 1 into minus 1 is minus 1, minus 1, 1 into 2 is 2, minus 1, minus 2 is minus 3, but there is a minus symbol outside, totally 3. So finally 3. Cofactor of 2, that is A31, is the value of this determinant, which is minus 5. Similarly, cofactor of minus 1, A32, third row, second column, this minus 1. So leave this column, leave this row, 1, 1, 1, minus 3. This negative symbol should be there outside. So minus 3, minus 1, minus 4. Because of this negative, it becomes plus 4. Similarly, for A33, for this 3, you will have the value turning out to be 1. And now this example is the question I am just repeating here, and then you see the remaining ones. cofactor matrix of A is 3 minus 1 minus 5 minus 4 1 3 minus 5 4 1. That is, you collect all the cofactors and you will form this matrix. The corresponding elements, the elements are replaced by their corresponding cofactors, and then you can see that cofactor matrix is written with a bracket like this. There's a bracket here, there's a bracket here. Then adjoint A is this matrix transpose, so the rows and columns will get interchanged. 3 minus 9 minus 5 first row, therefore transpose will have 3 minus 9 minus 5 as a first column, minus 4 1 3 as a second row, minus 4 1 3 will become the second column, minus 5 4 1 will be is a third row, here it will be third column. Therefore adjoint of the matrix A is transpose of the cofactor matrix, and the final matrix cofactor matrix adjoint of the matrix is 3 minus 4 minus 5 minus 9 1 4 minus 5 3 1.